This is section 312. We're going to use a graph to determine the inverse. So we're going to understand that the inverse graphs reflects over the line y equals x and graph the inverse function from an already graphed function. Now, if you remember in the previous lesson, we algebraically found the inverse by switching the y and the x value. Now, what that actually means is in an inverse function, the domain and the range are switched. So for example, if I have this function here with my x value 1, my y value 4, x value 2, y value 5, x value 3, y value 6. The inverse function, I actually just switch the x and y values. If you notice, they were switched. They were switched. They were switched. All you have to do is switch the x and y values. So, graphically speaking, if I wanted to graph the inverse, all I need to know is what the values are. So here we go. I have take these values and then you're going to plot them. And then the inverse, all I did is switch them. You swapped, 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 and then you plot those. So the red, that is the inverse function. Now I want you to notice something here real quick. There is this symmetry over this line, and this line here is y equals x. Every single inverse graph or inverse function is symmetric over that line y equals x. Every single time. So to find the inverse graph, we do three things, and it's going to help us visualize what's happening. First, we're going to draw the original graph with an xy table. Then we're going to draw in that line of symmetry y equals x. Then we're going to switch the x and y values from the original to start drawing the inverse. So let's do that. Let's just say here's my graph. And it's x squared plus 2. So that means that if I switch the x and y values, right, I want to go through and I want to switch the x and y values, right, that's going to help me create it. I'm going to draw in my line y equals x. Okay, so I have the original, I have my line y equals x, and then we go through and we switch them. And then if I switch them, so swapped, 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 I were to plot those, so 6, negative 2, 6, negative 2, boom. 3, negative 1, 2, 0, 3, 1, 6, 2. If you were to go through and plot those, then you can trace it and you can create a graph. Now notice, it has that symmetry over the y equals x. You could fold the graph over that line and they're going to line up perfectly. Here's another example. If I had the original here, y equals x cubed plus 1 or minus 1. If I graphed that, and then here's my y equals x. If I switch the x and y values, so instead of 1, 0, it's 0, 1. Instead of 0, negative 1, it's a negative 1, 0, right? If we go through and we switch all of those values, and then I can connect it and draw it, we can see that symmetry over the graph y equals x. So what did we learn today? We learned how to graph inverses. What lines are inverses symmetric over? That's going to be the line y equals x. And what do we swap to help us graph the inverse? The x or y values, or the domain and the range, right? Domain x, what range y. We're going to switch those. This does conclude our lesson. If you have any other questions, please leave them in the comments.